Hi guys, we're Tin and Queen. In this report, we will analyze the dataset to ensure what are the most accurate forecasts for the amount of employment in Australia for the next 10 months. Firstly, we prepare the data for analysis. The dataset was collected from the Australian Bureau of Statistics website, recording the amount of employment in Australia from 2015 to April 2025. Based on Figure 1, we can see that the amount of employment series experienced an upward trend with some visible short-term fluctuations throughout the series. This suggests a seasonal pattern. The observation seems to change smoothly through time, suggests an autoregressive behavior. Besides, there are no noticeable changing points within the series. Based on Figure 2, we can clearly see that there is seasonal pattern at lat 1, 2, 6, 7, 8, 9. According to the visualization of the partial autocorrelation, there's no seasonal pattern. Based on the stationary test, the p-value suggests that the time series is non-stationary. After some residual diagnostic, log strength formation, and original first difference step, we specify the following Sarima model. Looking at the autocorrelation and partial autocorrelation plot, there is no apparent seasonality left in both of the visualization. Besides, um, based on the three stationary tests, all the p-values suggest that the Sarima model has now been stationary. Having a look at the residual plot, the residuals fluctuate randomly around zero, uh, suggesting that the model has captured most of the systematic pattern in the data. However, there are noticeable spikes around 2020 and 2022, indicating potential outliers or structural changes, likely due to external shocks. And based on the ARMA table and BIC table, we select the five possible models as following.
This method, we select a particular ML model has the best model for the optimal efficiencies. Then we pick all the possible Sarima models and perform the combination test and find that Sarima 213 has all its combination significant. Further, in the AIC testings, we see the best option for the optimization. We see that Sarima 213 has a less values, cause Sarima 210 has some changing variation in the residuals. From other error measures, we see that Sarima 213 has a less values for its error measures. So this model is satisfy all requirements. Then we overfit the model and perform its residual analysis. Looking at our residual analysis, I will walk you through 6 important tests. From time series plots, we observe that there is constant variation with no obvious trends. Secondly, the histogram reveal ratios are approximately normally distributed. Similarity in the QQ plots, all points lie very close to the reference lines. That's the normality. In both ACF and BACF plots, so most correlation fall within the confidence bands. So most importantly, the Lichun post test results. So p value above 0.05 across different plots, confirming our residual behave like white noise. Let's see for our forecast. Let's see here our 10-month forecast using the best model, which is Sarima 213 from May 2025 to February 2026. The blue line show our podcast starting approximately at 8:20. 8.25 in May 2025 and projecting to approximately at 8.27 by February 2026. So in the gray and blue shading, so how the confidence intervals widening progressively over time effectively increase forecast uncertainty. Generally, it shows a gradually upward trend.